video, we'll try to understand the technical drawings or blueprints better. So let me start with types of technical drawings and then go down to what are the components of technical drawing. So firstly, we start with the type of technical drawing. So first one in front of me is elevation view drawing or front view drawing, where you have only one view. You have one view, that is front view in the drawing. So basically this drawing is of a valve. Now this front view is not an ordinary front view, it's a sectional front view, so that you can better understand the layout of the parts and how the parts are arranged in the valve. Usually in mechanical drawings we have sectional front view, whereas in civil engineering or construction they have elevation of the house or the building. So this is a typical example of elevation view drawing or front view drawing, where you have this sectional front view. Another type is floor plan. Here is the floor plan, where you can see the layout of the machine or the tool or the workshop. So it's like a basically map where you can show the arrangement of machinery or tools. Here is an example of floor plan. Another type of drawing is isometric drawing, where there is a 3D view in that drawing. So here is the example where you have a drawing for pump with coupling and pump motor. Here is another example of isometric drawing. Here is another example of isometric drawing. Another type of technical drawing is orthographic detail drawing, where you have orthographic views. Okay, here is the example of orthographic detail drawing, where you will see not necessarily two views, maybe there is 3 views or 4 views. Here you have 2 views, front view and side view. In mostly drawings it will be top view, front view, a side view, or just front view and side view. It depends if the views they are communicative enough, then they will be helped. Like for example, if 2 views are enough for the drawing to be communicated to the manufacturer or the technician or the machinist, then two views. If you need more than 2 views, like 3 views, top view, for better communication, better understanding of tolerances and details, then you will use 3 views. Another type of technical drawing is exploded view drawings. These drawings have exploded sectional views, which explains the location of the parts, how it can be assembled. Basically, when you buy a piece of furniture from furniture store or electronic devices, you get an exploded view so that you can assemble them in your home. So it's more communicative and better understanding. Even layman who doesn't know the technical things can understand the drawing. Here is another example of exploded view drawing, where you have an exploded view of front landing gear of aircraft. You can see how the parts are, how they can be assembled, And finally we have multi-view drawings. That means they contain both isometric drawings and orthographic drawings. That means both 2D and 3D, and they have multiple combinations. So here is one combination. You can see isometric 3D view and exploded view, and you can see 2D view. So it's multiple view drawing. So here is also another example of multi-view drawing. where you have an exploded view and isometric view. Here is another example for multi-view drawing, where you have an 3D isometric view and 2D orthographic view. So both of them are combined to communicate the drawing, so there is no chances of error. It increases the communication between engineers or companies or manufacturer or the client. Okay, now after understanding the type of technical drawings, now we'll go into the drawing itself and try to understand what are its components, what does they mean. So for a technical drawing to read, let me start with the grid system. Grid system, it's the border. You can see two lines here, A, B, C, D, E, and you can see here 1, 2, 3, 4, 5, 6. So you have border. It's basically the border which will help you to locate the parts. This is a simple drawing, but if you have a complicated drawings where you have many parts and you want to locate, or similar parts where you want to locate the part, you can use this. It's like basically like a map reading. Whereas if you have a map, how they locate the location in maps by latitude and longitudinal coordinates, two numbers basically, one is vertical, another one is horizontal, in the so that they pinpoint the location. So here also we can pinpoint a location by using this vertical alphabets against this horizontal numbers. For example, here if I zoom in, you see A and here is 1. So I just made a rough line with my pencil, a square or rectangle, whatever it is coming. So anything falls under this area will be in zone A, first the alphabet, then the number. So anything, any component, anything coming in this area of the drawing, it will be under zone A1. Okay, for example, let us see here, we have a bolt. So this bolt C, and we go up 8. So this bolt comes under the location zone C1, C8. Here like this you will read the different locations of the parts. So we learnt grid system, we call this lines grid system, and A1, A2, B2, B3, like this we call them zones. Next, another component of blueprint which is very important is revision block. Revision block gives you the details of revisions or the modification done and the date on which these modifications were done and who approved them. Okay, so here is a revision change from, there was change for something from 970 to 718 in the dimension on this date and done by whom. So you can keep a track, and this is usually is very, very important in terms of giving contracts. Once you give contract and then there is a dispute between contractor and client on the modification of the parts or the dimension, so they need to go review this revision block, who was the one who did the modification, then why he did the modification. And so this is a typical example of revision block. And about the location of this revision block is basically located, this is title block, I will explain later, is usually located beside the title block or here on the left bottom side or on the top right side. So wherever the drawing technician feels comfortable, he puts it, place it. So another drawing, you have a revision, let's find the revision block here. It's not located here, not located here. So let's go to the favorite place. Yeah, it's located here. So you see the revision. Usually revisions will be written on the top of it, and you will see REV and the number of revisions, that means, and description, what was done, date, check. Okay, the next is the most important component in the drawing, which is title block. Title block is a massive block or massive component of blueprint after drawing, engineering drawing. After engineering drawing, this is the most biggest part in the technical drawing, where you have all the information. Mostly all the majority of the information is available. Contractor, client information, who is the client, who is the contractor, what is the name of the part, what is the name of the company, what are the things, who is responsible, tolerances, material, finish, each and every detail will be in the title block. Title block starts from here, goes. Okay, now like right now in this drawing we can see this company name, and this is the back top slide, the part name. This is the part, and you have the drawing number, you have revisions, how many revisions. Now drawing number, let me find another drawing which has a good drawing number. Drawing number usually come in a practical standard. There is a standard for giving drawing number. It's you can Google it if you write drawing number standard. So basically, you know, they keep the location of the machine and the tag number and the CAD number, where the computer, in the computer where it is file number. They will give codes each number so that you can locate the drawing. So here drawing number is the company name and some shelf name or the code which they have given. So in the title block itself you will find a projection symbol, which is again important component in understanding how the method of drawing has been followed, like first angle projection or third angle projection. In first angle projection everything is like quite a bit opposite to third angle projection. In third angle projection, top view is in the top, right is on the right, and left is on the left, and bottom is on the bottom. Whereas in first angle projection everything is going opposite. Top view you will find it in the bottom, and bottom on the top, right on the left, left on the right. So you get type of projection from this, which is again in title block. Now in title block you have this column material, where it specifies the material of this part. So here you see code like 6061 T6. It is an alloy code, aluminum alloy. Basically they don't write each and every composition of the metal. They will use the code ASME codes or standard codes for the materials or the type of alloys, where these alloys have specific strengths, mechanical properties, and metallurgical structure. So right now they are using this material T6061 and T6. So if you go to the code book, you can get the material, more details in the material, what are the components or composition of the material. Now let's see another example for material. Okay, here he did not mention it. Now after material you have finish. So here in the finish is just like the end machining or end work. In the last, how do you finish your product? Once you manufacture it, how do you finish it? So it's asking you to see note 2. So we need to find note 2. Where is it? Note 2? It's not there, and it's here, note 2. So you have two notes here, note 1 and note 2. So it was asking us to go to note 2. So here is the note 2, anodized, type 3, class 2, black. So basically this is the finish, end finish they want. It's like it will be the last coating on the component. How they will do it: this is the type of coating, anodized type 3 class 2, black color. The color will be black. So this component, when it is done, the coating for this one will be like anodized, it's like aluminum coating, so it will be class 2. This coating, if you type it in Google, anodized type 3 class 2 black, you will see images for the components coated with this coating. So this is the end finishing of the component. So it is again in the title block, finish. So here is another drawing. So material is not there, but you have finish here, surface finish. So surface finish, you have at 125 RA roughness average. This is RA roughness average 125. So this is basically a machine finish, like get the finishing by a machine. Actually, what is a finish means? It's like the end thing, what you do to your product, make it more attractive or efficient. You have another example here. So this is the valve. So finishing, machine polished. So machine polished. So what is polishing? Finishing is machine polished. So what is polishing? It's just making the surface smooth and reflective and shiny, you know. Here another inside finish and outside finish. See, mirror finish, the same thing, making it more smooth and shiny and reflective. Another important component inside title block, you will have tolerances. So these are the tolerances mentioned. Basically there will be different types of time tolerances. So here it is mentioned .xx. When it is written, the tolerance will be plus or minus 0.03, and sometimes they give the code, so you have to follow the code as per the code, standard code. You will go back to the whatever code, ANSI or ASME, and refer to the code book and try to find the tolerances. Here they mention the tolerances itself. I'll give you another example. Another example for tolerances is here. You have this drawing for drive gears. Now here they give the code which I mentioned earlier, as per dimension and tolerances as per ANSI Y 14.5 1982. So if you go to this code book, if you go to this code in code book, you will get all the tolerances for this component. Airbags also they have mentioned dimension without tolerance or limits are subjected to this. So if there is this without tolerances, so you have codes also given, angular tolerances, and so you have bilateral tolerances given in this drawing. Coming to the component, another important component, that is bill of material, or sometimes you call it part list, as you wish. Some people call it part list or some people call it bill of material. It is very famous as bill of material. So basically in the bill of material, what you have is serial number, part name, sometimes drawing number is there or sometimes it's not there, description of the part, and quantity. Major three things will be for sure: serial number, part name, and quantity. Description or material will be added. So this is one example where you have a valve and you have these parts. So you can say total number of parts in the drawing is 21. So this is the location of the part, number 7. What is number 7? So you go number 7, diaphragm. This is how you know the parts. The details of the parts also sometimes are given, like diaphragm of this material, of this grade, etc. Another example for bill of material. Here you have a bill of material. Oh, it's not that much clear. Let me shift. This is the bill of material. It's not clear. Let me go to another drawing. Here is another drawing, the front landing gear of an airplane. So this is the bill of material. What do you have? Same thing: serial number or the item number, quantity, part number, description. See here, they described well with the material. What is the material required for this, each and specific component, and how many quantities you need. Another example for bill of material or part list: quantity, item number, quantity, part number, description. So they have described for body, this part number, this is the part number, and for this key plate, this is the part number. So they have specified each and every part with some number, and this is the part list. Here they don't have anything in the part list. Let's go to another one. Here there is only one part, so they don't thought it necessary to put part list. So to conclude, we can say we saw the basic type of technical drawings or blueprint, and we discussed about blueprint components. So in order to review, let me just review up all the things. We discussed about elevation view drawing, that is in front of me. Then we discussed about floor plans. Then we discussed about isometric drawing. Then we discussed about orthographic drawings. Then exploded view drawings. Then we discussed, after exploded, we discussed about multi-view drawings, where you have combination of both exploded and isometric, exploded and orthographic. Here also you have combination of isometric and orthographic, like 2D and 3D together. And then we discuss about the components of technical drawing, like title block, grid system, and part list, and revision block, which is most important, revision block, and projection symbol, and material and finish. That's it.